Okay, so let's add some rational expressions that do not have that common denominator. It has an unlike denominator. So it says, what is the sum of this rational expression and this rational expression? So we're going to write out this as an addition problem, but what we notice right away is that the denominators are not the same. Remember in the other video, I talked about when you can see the denominators in factored form, you can identify what might already be the same and what else is needed to make them a common denominator. So as we rewrite the problem, let's factor our denominators. So we have an x plus 3 over that x squared minus 1, that's your difference of squares. So x plus 1, x minus 1 plus, because they said it's addition, find the sum. 2 over, factoring that denominator, it's a trinomial. Factors of 2 that add up to negative 3. That's going to be x minus 1 times x minus 2. All right, now we get a better look at our addition problem. We do not have a common denominator. It's not exactly the same, but there are elements that are the same. They both have an x minus 1, so that's already common. So what else do we need so that the rest of it is the same? So I notice that on the left we have an x plus 1. So we need to, you can get common denominators with multiplication. We're going to multiply in an x plus 1 to the other fraction. Now both fractions have an x plus 1 and an x minus 1, an x plus 1 and an x minus 1. You probably have noticed that this one on the right has this x minus 2 that we're missing from over here. So with multiplication, we are going to multiply in that x minus 2. And when you guys are getting common denominators, whatever you multiply into the bottom, you have to multiply into the top. Okay, so when you multiply in to create a common denominator, you likely will have a little bit of prep work to do with these numerators. The denominator, we don't want to multiply that out. We're going to leave the denominator as is, but we do want to multiply out our numerators because we're about to add them together. And when we add our like terms, and I don't know what the like terms are until they're multiplied out. So I'm just going to say, all right, I'm going to multiply this just off on the side. Here's my work, x minus 2 times x plus 3. Remember, this is distribute the x times x is x squared, x times 3 is 3x. Now distribute the negative 2. Combine like terms, we have x squared plus x minus 6. Here, maybe I'll even cross that off and write that above. X squared plus x minus 6. All right, then we have this numerator, 2 times x plus 1. Let's distribute the 2. 2 times x, 2 times a positive 1 is plus 2. So this is now a 2x plus 2. All right, this is looking good. Now we are adding two fractions together. We have a common denominator. So I'm going to carry that over. I know it's going to be an x minus 1 times x minus 2 times x plus 1. And then we're going to add our numerators. Well, our first numerator is x squared plus x minus 6. We're going to add to that the other numerator, 2x plus 2. All right, so in the numerator, we're looking for like terms. We have an x squared. There are no other x squared, so that's going to stay. We have a positive x plus a 2x, so x plus 2x gives us 3x. And we have a negative 6 plus 2. Negative 6 plus 2 is a negative 4 all over our denominator, x minus 1, x minus 2 times x plus 1. All right, before we continue on, we are going to stop and identify our domain because we're going to try to simplify this down if we can, but we want to get our domain before we do any simplifying. So the domain, our x's cannot equal. Remember, if you set all of these equal to 0, all those factors, you're going to get a positive 1, a positive 2, and a negative 1. Just a reminder that domain, if you were to plug in a 1 for your x, 1 minus 1 is 0, and 0 times this makes that whole denominator 0. So x can't equal a 1. We're not going to let that happen. X also cannot equal a 2 because if we put a 2 in for this x, 2 minus 2 is 0. 0 times this gives us a 0 denominator. It's undefined. We're not going to let that happen. So that's why we identify that domain. All right, so back to our problem. Can we do any simplifying here? Let's see, we have, if we can, so our denominator is already factored. Can we factor the numerator and get anything to cancel? Now it's like what we had in a previous lesson where it's just a rational expression. Can we simplify it? Can we reduce this down? Are there factors of -4 that add up to a positive 3? And there are factors of -4 that add up to positive 3. That's going to be an x plus 4 times an x minus 1. And then our denominator, x minus 1, x minus 2, x plus 1. Now that everything is factored, do we get anything to reduce? We can cancel an x minus 1 on the top with an x minus 1 on the bottom. Do any other factors cancel? And we don't see anything else canceling. So our final answer, we have an x plus 4 on the top. Our denominator is x minus 2 times x plus 1. So the sum of those two original rational expressions is this for all the x's, as long as x does not equal 1, 2, and -1.